Okay, Gen Chemers, one more lecture for Module 3. And in this lecture, we're going to look at the organization of the periodic table, and we're going to learn how to navigate with the periodic table and then introduce the concept of ions. So let's get started. Okay, so Dmitry Mendeleev is known sort of as the father of chemistry. He was a Russian chemist who ordered elements by atomic mass. And when he did this, he noticed that there were certain chemical and physical properties that were similar. So he arranged elements in columns based on similar chemical and physical properties. And he left open spaces in the table for elements not yet discovered. So what he did was he organized the elements in a way that sort of put all of the elements that had similar chemical and physical properties in a column or a group. And then he found that periodically various properties tended to cycle through the different elements. This resulted in our modern periodic table, where horizontal rows are called periods, and then vertical columns are called groups or families. Elements in the same group tend to have the same physical and chemical properties. Elements are divided into three broad categories. I want to look at metals, nonmetals, and metalloids. Metals are on the left side and bottom of the table. They have some very characteristic properties. They're shiny solids, they conduct heat and electricity, they're malleable, they're ductile. Nonmetals are on the right side and at the top. These have a diversity of physical states. Metals tend to be solids. Nonmetals can be solids, liquids, or gases. They're non-conductors, and if they are a solid, they happen to be brittle. Metalloids are somewhere in between. They can have properties that can be like metals. For example, they're typically shiny solids. They also have properties that can be like nonmetals in the fact that they're brittle or they're semiconductors. When you look at a periodic table, this is sort of what you're going to see. Hydrogen is a nonmetal, but it's over here on the left top because it's very similar in terms of its electron makeup with other elements that are in group 1A. This stair step here is the band of metalloids. So boron, silicon, GeAs, Sb, antimony, tellurium, those guys are all considered to be metalloids. And then in the blue, we have our nonmetals. You can tell that by far the most common type of element would fall into the metal category. So metals lie on the lower left and the middle of the periodic table. You need to know these properties. They're good conductors of heat and electricity. They're malleable, which means they can be pounded into flat sheets. They're ductile, which means they can be drawn into wires. They're often shiny. Here's the big one. They tend to lose electrons when they undergo chemical changes. They lose electrons when they undergo chemical changes. Nonmetals that are on the upper right-hand side of the periodic table, there's not that many of them. And they have a variety of physical states at room temperature under atmospheric pressure. 5 are solids, 1 is a liquid, and 11 are gases. Metalloids, they're sometimes called semimetals. They're elements that lie along that zigzag or that stair step that divides the metals from the nonmetals. They actually exhibit mixed properties. Interestingly, several metalloids are also classified as semiconductors, and they're very useful in various industries. Okay, I have another sort of distinguishing feature on the periodic table. I could have main group elements. These are also called representative elements. And those are column 1A to 2A, and then columns 3A to 8A. What these main group elements tend to have properties that are largely predictable based on position in the periodic table. Then I have transition metals. These are the B groups, 3A to 2B, 3A to 2B, 3B to 2B. There's 8 groups or 10 columns. Those are sort of the middle of the periodic table. These properties are less predictable based on their position. These can do a lot of different things. They have a robust chemistry associated with them, and we're going to focus a lot on, in this course, on main group elements. So here's how I distinguish this middle section. All of these blue elements, those are my transition metals. Anything in yellow are going to be my main group or my representative elements. My inner transition metals are going to be on the bottom of the chart, sort of separated from everything. The top row are called the lanthanides. The bottom row are called the actinides. Now, let's look at individual groups of elements. Group 1A, so the first column, are called alkali metals. So group 1A, not including hydrogen. These elements are called alkali metals, and they're very, very reactive. In fact, I could take a marble-sized piece of sodium, and when I drop it into water, it is going to react violently. Other columns or other elements in this column include lithium, potassium, rubidium. You can see here, this is sort of an example of a reaction with water. I produce a large quantity of heat, and I also produce hydrogen gas, which ignites. And I end up with this sort of burst of flame, and then it sort of propels itself around the beaker. You can look at that stuff if you look up sodium reacting with water on YouTube. The second column, anything in group 2A, those are called the alkaline earth metals. They're fairly reactive, but they're not quite as reactive as the alkali metals. Calcium will react vigorously. Other metals in this category include magnesium, strontium, and barium. Next, I go down all the way to the right and I look at group 7A. These are called the halogens. These are very reactive nonmetals. Fluorine, chlorine, bromine, iodine, those are really commonly occurring elements in various compounds that we're going to study. They're so reactive that when they're found in nature, they're found as a salt. If I do look at elemental chlorine, it's a greenish yellow gas. Bromine is actually that one red liquid among the nonmetals. Iodine is a purple solid, and fluorine is a pale yellow gas. They're we're gonna be exposed to them a lot. So make sure you know that that column is in 7A is going to be the halogens. 8A, the very last column on the periodic table. Those are called my noble gases. They're mostly unreactive. They used to be called inert, but we do know that there are compounds that can be made from various noble gases, so I really can't call them inert or totally unreactive. The most familiar noble gas is probably helium. If you ever get a Mylar balloon for someone's birthday, or you fill regular balloons for various balloon bouquets or whatever, you'll notice that helium is less dense than air, so it floats in the air. Helium is chemically stable. It does not combine with other elements to form compounds, so it's safe to put in balloons. Other noble gases would be neons. If you've seen neon signs, that's the gas that is in those signs. Argon is a small component of our atmosphere. This category also includes krypton and xenon. Now, ions. Remember when I said that the number of electrons in a neutral atom is equal to the number of protons in its nucleus? When elements undergo chemical changes, sometimes atoms can gain or lose electrons. In this case, they become charged particles and they're called ions. If my ion that results is positively charged, which means I lose negative charge, which means I lose electrons, I become a positively charged cation. Negatively charged anions, to form a negatively charged anion, I gain electrons. I'm going to gain negative charge, right? Those negatively charged particles are called anions. Remember I said metals tend to lose electrons when they undergo reactions. So main group metals will lose electrons, and the number of electrons that they lose are predictable. They will lose the same number of electrons to become isoelectronic as the nearest noble gas. They want to lose electrons until they have the same number of electrons as the nearest noble gas. I want to be like a noble gas. My main group nonmetals, again, main group, predictable, will gain electrons, right? So my main group nonmetal, they'll gain electrons to form an anion that has the same number of electrons as the nearest noble gas. So these charges are predictable. And I can tell based on the periodic table and the position on the periodic table what charge is going to form either from the metal or the non-metal based on the position in the periodic table. So, alkali metals, metals in group 1, lose 1 electron and form +1 ions. Alkaline earth metals, group 2A, tend to lose 2 electrons. They form 2+ ions. Halogens, now I'm in the non-metal, right? They gain 1 electron. They form -1 ions. Oxygen, which is in group 6A, gains 2 electrons and forms 2-. So every metal in group 1A forms a +1 cation. Every metal in group 2A forms a 2+ cation. When I go to the other side and I consider nonmetals, If halogens form ions, they're going to gain 1 electron and form a -1 charged anion. If I'm in the family that contains oxygen in group 6A, that is going to gain, those elements are going to gain 2 electrons if they ionize and form anions that have a 2- charge. So for the main group elements, when I form cations, the charge that's formed is equal to the group number. So if I'm in group 1A, I lose 1 electron, become +1. The charge is a +1. If I'm in group 2A, I lose 2 electrons, become 2+. The charge is equal to the group number. If I form anions, the charge is equal to the group number -8. So if I'm in group number 7 and I take away 8, I have a -1 charge. If I'm in group number 6 and I take away 8, I have a -2 charge. Transition metals, they form various different charges. They're called multivalent. They are not predictable. I cannot predict the ion that forms from transition metals. So here's a chart that's really important. This shows elements that form ions that have predictable charges. Again, group 1A forms +1 cations. Group 2A forms +2 cations. Aluminum is a group 3 element. I lose 3 electrons to become like the noble gas before it. Aluminum will form a cation with a +3 charge. Here, I want to go 1, 2, 3. I want to gain electrons. I'll become -3. If nitrogen forms an ion, it's going to be a -3 anion. Oxygen, 1, 2, to become a noble gas in the row next to it. So if oxygen or anything in group 6 ionizes, it forms a -2 charge. Halogens will form a negative charge. Notice hydrogen can also form a hydride, which is a -1. This is a good chart to sort of keep your eye on. Keep your eye on the ions. Oh, I just made a funny. Anyway, you have to be able to look at the group number and then look at the charges that will be formed. When we start making ionic compounds and looking at covalent compounds and how atoms bond, we're going to have to know what charges are formed in order to put these ions together to form stable ionic compounds. So this is all going to be very important in the next segment of the class, which is going to be looking at ionic compounds and how they're put together in predictable ratios. My non-predictable ions are those ions that are formed from transition metals. For example, chromium can form either a chromium +2 ion or a chromium +3 ion. It can lose 2 electrons or it can lose 3 electrons. It is multivalent. Same thing with iron. I can form +2 or +3. Iron 2 will lose 2 electrons, or that ion that results from the loss of 2 electrons is called iron 2. The ion that results when iron loses 3 electrons has a +3 charge is called iron 3. Lead is a representative element, but it forms different charges. So even though it's in the representative element, this is a multivalent atom. Lead can either lose 2 electrons to form a +2 or lose 4 electrons to form a +4. Tin is also a representative element. Those are the ones I really have to pay attention to. They're not in the transition metal block, but they are in fact multivalent. Tin can lose 2 or 4 electrons. It can form a +2 tin or a +4 tin. Gold can be +1 or +3. Notice these parentheses contain a Roman numeral. The Roman numeral is actually indicative of the charge that is formed by the loss of a particular number of electrons. Gold 1 loses 1 electron and becomes +1. Gold 3 loses 3 electrons and becomes +3. Copper is another multivalent atom. It can lose 1 electron and form copper 1 ions, which are positively charged, 1 positive charge, or it can lose 2 electrons and become +2, copper 2. Same with manganese and cobalt. So my transition metals and lead and tin, these are my problem children. These are the ones that I have to have more information in order to determine which ion is formed when it forms ionic compounds. That is going to be a topic for another day. And with that, we conclude Module 3. Good night, everybody. Good night.